Oke, Bapak Ibu semua, mohon izin, bisa didengar suara saya dengan jelas?
Bisa Pak Ferry?
Alhamdulillah.
Bisa Pak Ferry.
Bingbing?
Bisa Pak Ferry.
Bingbing?
Yes.
Are you there? Can you hear me clearly?
Yeah, yes.
Okay, so I think we're gonna start. So now we have more than 150 participants. So I think we're gonna start now, Bingbing. Okay.
Okay.
Okay. Thank you so much. Okay.
Thank you.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
So today is the first general lectures on education and research in industrial engineering. And as we scheduled for this morning, so the talk will be delivered by Associate Professor Bingbing Lee, Ph.D. So he is a professor at California State University, Northridge. So Northridge is in what north part of LA. Is that right, Professor Bingbing?
Oh yeah, Northridge is a small district or community in the Los Angeles city.
Okay, so it
is north part of Los Angeles city. Yes.
So it is part of the LA County, right?
City and the county, yes.
City and county. Okay, so that's about Northridge. So in California. So Professor Bingbing, so he got his PhD from Texas Tech University in Texas, United States of America, and also he got his master degree from, you got it from China, right, Bingbing?
Yes.
Yeah. So he got it from Hefei University of Technology in China, and he also got his undergraduate degree in engineering from the same university in China. So actually, Professor Bingbing is my lab mate when I was a PhD student in the US. So we were working under the same professor, and the name of that professor is Professor Hong Chao Zhang. And now in Texas Tech, he is about to retire. Okay, so this morning, Professor Bingbing will share his experience. He will share his knowledge on two things. So the speech or the talk will be divided into two parts. Part one, Professor Bingbing will share his research area. So Professor Bingbing research area is in the area of 3D printing, additive manufacturing, smart manufacturing, life cycle assessment, and sustainable manufacturing. That's part one. So he gonna give us the overview. What is the current trend in the area of 3D printing, smart manufacturing, and sustainable manufacturing. So that's gonna be the part one. And part two, I think this is the most important part. So if in the part one he discussed his research, and in part two, in his presentation, he will share his experience in education, especially for the undergraduate education. So we specifically asked Professor Bingbing to share his knowledge for a particular course in the US, and that particular course is a compulsory course for any engineering school in the US, for any engineering institution who give engineering degree for the undergraduate students. And the name of that course is the Senior Design Project. So for us in Indonesia, the Senior Design Project is the final project, but there is a very big difference between the Senior Design Project and the final project. So in the US, the Senior Design Project means a students or a group of students, they need to design something. They have to design something. So they have to design a prototype of a product based on the knowledge and skill that they got during their education. So that's what they do in the US. So for the undergraduate student in the US, they do not require the student to do research, but they require the student to do design. So every student, group of students, they're gonna come up with a product, a real prototype product from their design. And the assignment can be from the industry, and the assignment can also be from the advisor or from the professor. That's what we're gonna see what they have in the US regarding the senior design projects. So as we know right now, if we want to get international accreditation, for example, if we want to get ABET accreditation, that's one thing that ABET will ask the program. Do you require your student to have design experience? They will ask that because that is compulsory, that is a must. So with ABET, they do not require the students to do research. No, we do not produce researcher, but we're gonna produce people that's gonna work in the industry. And when they work in the industry, they need to have design skill. That's what Professor Bingbing will share with us. And for all the participants, we're gonna have 2 hours. So we're gonna have until 11:15 or 11:10, and I'm gonna be the moderator of the talk, and we're gonna give Professor Bingbing 30 minutes maximum to deliver his speech, to present his experience and knowledge, and then after that we're gonna continue with Q&A, question and answer, and feel free to ask Professor Bingbing anything. Your question can be something that is related to the topic of the event right now, or it can be anything that is related to research and education in industrial engineering in general. And also for students, I encourage you, all of you, to ask anything to Professor Bingbing, to ask for any opportunity that you think that you can get in the US, especially in CSUN, in California State University, Northridge. So there are 2 ways to ask a question. Number 1, you can ask question by typing your question in the chat window. That's number 1. And number 2, and I very encourage everybody to ask question by using method number 2. That is by directly ask Professor Bingbing by activating your video and your microphone. So ask him directly. If you are not confident with your English, that is fine. I'm gonna do my best to help you to translate your question from Bahasa Indonesia to English. So if you want to ask question by using the chat window, you can type it even when Professor Bingbing has not finished his presentation. But for the question that you're gonna ask him directly, then you need to wait until Professor Bingbing finish his presentation. And I'm gonna let you ask your question. You need a permission from me to ask a question to Professor Bingbing. So after I say yes, now you can go ask your question to Professor Bingbing. Then you go. You cannot just talk or ask question directly to Professor Bingbing. I think that is it. I think that is very clear. That is the rule of the games. And Professor Bingbing, are you ready?
Yes.
Okay, now you have 30 minutes maximum.
Okay. Yeah, it's yeah, thank you so much, Chair Ferry. It's my great pleasure to make the presentation today. And I saw, okay, right now we have 175 audience participants. So this is the largest Zoom meeting I participated since the COVID-19 pandemic. So I think right now the globalized, everyone just suffering for the COVID-19, and I just want to give you the best wishes, and then I hope everyone will stay safe and healthy, including yourself, your family members, and we can survive, out of this pandemic as soon as possible. Yeah, as introduced by Ferry, your chair, Ferry, and then today my topic will be the research part, two parts. Part one is research in my area, and second one will be education. But you only give me 30 minutes, I have pressure, so I will try my best to get it done in 30 minutes. Okay.
Okay. Take your time.
Yeah, that's fine.
Take your time. Yeah, take your
yeah.
time. That's okay.
Yeah, sure. Like here's my background. I think Ferry already introduced. Like I got my bachelor and master degree in mechanical engineering from China, and got a PhD degree in industrial engineer from US in Texas Tech, the same doctor advisor and the same university with your chair Ferry. And I also did 1 year postdoctor in the University of Wisconsin. So I joined CSUN in 2014. And then I got promoted to associate professor in the past summer. And here I also have some couple of, few professional appointments as well. And this is for the research project. Like I was a faculty mentor of U.S. Department of Education, the NIH Bill Polder program for the research to supervise most of them is undergraduate students, because here, CSUN, California State Northridge, is part of 21 of the 23 campuses in the CSU system, California State University system. And it's not like a UC, Berkeley, UCLA, you heard that's the tier 1 research universities, they have PhD program. But here's in the engineering school, we don't have PhD program, we only have master and undergraduate students. So most of our research is designed for the undergraduate student and the master student. I'm also the faculty lead in the NASA's Autonomy Research Center, and then I'm really excited to share with you, like Terasaki Institute for Biomedical Institute. I joined this institute as affiliate faculty last month because they are working on the biomedical and the bioprinting in research. The CEO is a world famous professor, so I'm really excited to work with them. So actually, before this meeting, good morning. Sorry, yeah. Right now it's evening, Friday in Los Angeles time, local time. So here's the brief of my external grants. Overall, I got 9 grants from the US. Typically, it's from the federal government, like NSF and DOD and DOE. And total, like as PI, I got over $800,000, and as a co-PI is around $750,000. And these are some of the internal grants I got from CSUN. So most of them is, to establish my research lab. I got some internal funds to purchase some equipment, to build up, hire some students as assistant to establishing my lab, especially like a 3D bioprinting lab. Here is my research area. Before I joined CSUN, most of my research areas is similar to, I think, Chair Ferry, sustainable design and manufacturing, like life cycle assessment, the green manufacturing efficiency, and the remanufacturing. But after I starting my postdoctoral research, I started working on the additive manufacturing, like 3D bioprinting and the metal printing. These two are the most two concentrated area I'm working now. I will share these different projects in the next few slides. And 2 years ago, I started working on the, I think today, right now it's 2020, so I think it's 3 years ago, I started working on the smart manufacturing, specifically on the digital twin, smart connected worker, and the process simulation. So these are my current research highlights. Here's some facility in my own lab. Not belong to the department, it's my own lab. My department have more equipments, different equipment, but this is all the facility equipment in my own research lab. So this was funded by the DoD, the $500,000 grant, and then we purchased the Renaissance AM400. This is the metal 3D printer, use laser, and then this is Strassys dimension, U-print, all these different SLA printers, the thermal jet, and also the desktop 3D printer. I think that will be more familiar to you. Like right now, I think from worldwide, a lot of the universities have these desktop entry level, 3D printers. And in the US, even the high school, the middle school, they have purchased these 3D printers for the students for their projects. And these are the 3D bioprinters we developed in our lab and by our students and by by my grants. So we just build these. You can see these our 3D bioprinters from scratch, and then we design and manufacture these 3 different 3D bioprinters. And these are the equipment we purchased for my cell culture because I'm working on the 3D bioprinting. So we have to grow the cells and then put the cells in the hydrogel. So I will show you details later, like how we are going to, how we are working on the 3D bioprinting. This is a new emerging research area. Okay, next I will, in my research, I divided it into 2 sections. The first one is 3D printing. And the design for AM. These are some of the grants, support for this research area. I think you are the students I think most of you are in the student in industrial engineer major, right?
Yes.
Okay.
Yeah. All of us
Yeah,
are
I think, and
the
then
IE students.
Okay, IE students. So I think maybe you already have the knowledge of 3D printing, additive manufacturing. This is the definition. I think they have different definitions for from different country or different group of people. But this is the definition of 3D printing from ASTM in the US. So typically the AM means is the process of joining the materials to make the object, right, from 3D model data. And US, the first the nationwide institute founded by the DoD was the American Mix. It's the most famous one. I will introduce that later in the overall. There are 14 national institutes for the manufacturing. So additive manufacturing, I think they have a lot of advantages, right? And like they can reduce the 50% and by the energy and then 90% of materials cost. So these are the different 3D printing technologies like inkjet-based, SLA, extrusion-based, LCLS, FDM, the laser-based. I think you may be familiar with them. If you're not, and learn later in the Q&A section, I can give you more details if you have any question about each of the technology. But here, I just want to give you a brief introduction. And then the 3D printing process itself is from the model, right? You build a model in the different software, SolidWorks, CATIA, Autodesk, Inventor, Fusion 360, right? And then the pre-processing, so they will generate G-code. And then there will be the manufacturing process, and then there will be 3D printing, 3D printed construct. So the first, so I'm going to share all the projects that I'm doing, either I have done or I'm working now, right? And then to show what the different projects, so you will have a better idea of the current research in the United States, right? So for the first one is the most recent projects in the metal 3D printing, like the porous titanium scaffold for the cell availabilities in the bone tissue engineer. This is the bone tissue structure. I think that you may be familiar or you get the basic idea what's the bone structure in even I think from your high school biology, the class. So the purpose of this research is we're trying to mimic or simulate the bone structure, especially the porosity. So over here, they get more detail like these compacts in the bone tissue. Spongy is this porous, the scaffold or porous structure. And then our ideas, our design methodologies through the 3D software or the modeling, a lot of the creation structure with multi position similar to the human bone. And here, because I'm not going to go more details like how we choose this 300, 400, 500, because later on, if you have questions, then you can ask in the Q&A. So here's what we did is we design in the software, we use Rhino and the Grasshopper interlattice to create these 3D geometry and the structures, right? And then we test them. So we build them in the 3D modeling. Like we also pick up the different variables of this structure, the scaffold. The pore size is 300, 400, 500 micron. And then the cell geometry, we pick a 4. Diamond, honeycomb 1, honeycomb 2, and the grid. And then we generate a 5 by 5 by 5 millimeter cube. And then we generate these different structures and in the software. And then we also mimic the bone shape, for this semi-bone shape. And then we calculate the porosity for each geometry, for each structure. And then we use the metal 3D printer, but this one, since my 3D printer has not been installed at that time, so I just use my partner's metal 3D printer, this Concept Laser M2, to print out all these different samples and the scaffold from the metal 3D printer. So later on, I can also show you the more details of this one as well, And then we just use the microscope to look at the structure and also the deformation as well, because the slicing, if you are familiar with the 3D printing, they will have a lot of deformation, right? Like enlargement, missing links, and here is like a 20% enlargement because your design is 300 micron, right? But the real size maybe is larger than that. And then we also take the SEM image to look at the internal structure from the micro scale, right? And then we just want to know the internal structures based on the build, based on the fabrication. You can see this is honeycomb 2, honeycomb 1, and then you can clearly see some missing links over here, right? And deformation as well, like the initial, the shape of in the SolidWorks, in the software, is perfect, great honeycomb or the diamond. But after you print, there will have a lot of the deformation. But for the reason why we don't care about this rough surface is this is for the bone tissue. So the cells will be attached to the surface and then grow into tissue. So we don't need the perfect, surface finish for this project. We also did a compression test to see whether these structures will be able to afford the tensile test, right? Will be as strong as the human bone, because for the human bone, the high compressive strength is 170 megapascal. And then for all different samples, you can see, except the diamond, this ring is lower than the 170, and these two, like grade 400, 500 is less than 170, and then most of them is stronger than the human bone. And then we also put the cell. The second step is we're going to test the cell availability, whether these cells can survive in this structure. So we did the cell culture and the fakes, and then test them. So we put them in the cell in the scaffold for 30 days, and then we change the medias every other days. And these are the the cell counting from the device. And then eventually this is the final result after 30 days cell culturing. And then we can see this ADE, these three pictures showing they have a highest cell proliferation, around like 86%, right? This is really good result, so we showed them. So this is one of the projects, you can see the role of 3D printing in the bone tissue. The second project is the project we work funded by the SF, granted by the working with the local company. It's a Harley Davidson motorcycle. This is the most popular motorcycle in the world, especially in the US. So we're trying to get the 3D printing cams plate. So this is the motorcycle, and this is the principle, right? And then we're trying to find alternative fabrication way to make this cam support. Cam support is hold the camshaft, right, from this engine, and then facilitate the oil lubrication from the oil pump. And then what we did is we got this one from this company, from Harley Davidson, and then we do the reverse engineer. So we use this 3D scanner to get this model, the SolidWorks model, and then we redesign them. This is the old model you can see, and then we redesign. So the original design is because of the traditional machining, right? Drilling, milling, and turning. So they have to make the straight hole, like this one, straight hole, this straight hole. Otherwise, you cannot make it, these holes, or drill this hole. So, but for the 3D printing, they provide the potential to make a complex geometry, right? So, because these internal channels, they have the bad fluid performance. So we just improve that in this way to get a curved internal way. So the fluid, the oil will flow more smoothly inside of the engine, right? So that's our idea. And then we also design these different shape of the the holes, like a circle, diamond, oval, and teardrop. The reason why is I will show you later, because the 3D printing technology itself, they also have the disadvantage, because some of the structures, they will collapse. So that's why we have to design this way. We cannot design like a perfect circle, but after printing, they will deform and they will collapse. So anyway, that's why like has been proved like teardrop and oval, that would be the perfect the shape for 3D printing technology. And then we also did the fluid simulation to check how much performance or the efficiency we can achieve or we can improve to change from this sharp corner to this curved or the circle shape. So we also did the topology optimization. This is the new idea for the lightweight design. For the lightweight design, for these parties partition, we can call them partition, and then they will be the critical parts. Other than that, and then all these the bodies, they can be reduced or they can be changed to the meshed structure, right? And then we can save a lot of mass. So that's the purpose of topology optimization. So here you can see this is the real print. We use aluminum and still use the concept laser M2 metal 3D printer after the build, and then we have to remove the remaining metal powders. And then you can see here, this clearly see this, even we put the support materials, they still have the deformation, because this one's supposed to be a perfect circle shape. But now this is like an oval shape, because the metal powders, the residual stress, and then they will be change the shape. So another project, this is the project for the class, because this NSF projects, we collaborate with Kansas State University, Texas Tech University, working on to create a new curriculum in the 3D printing, and then we supervise the student to do the project. So this is the student project they did 2 years ago. It's a skateboard topology optimization. So this is the traditional skateboard, right? And then you can see, the topology optimization itself had been broadly used in 2 areas. One is aerospace, because aerospace lightweight is the most critical, the criteria, because if you can save mass and the weight, and then you can carry more equipment into the space, right? For airplane, for satellite, for aerospace, and for NASA, the project. And another area is architecture. Architecture, you can see all these pretty fancy and cool structures, right? So our purpose is, for this skateboard, we just want to design and save a lot of weight. It's like a lightweight design. We want to save over 70% of the weight, or reduce, right? So we just create the model, and then put into the software is Inspire. It's Altair solid thinking Inspire software, and then we run, set up the parameters, and then eventually you can see we can get these different the polymer model. They connect these structures, and then also they will create a lot of these mesh structure, the polymer structure, to save the materials, to reduce the weight. And then this is the final result. Like we apply the different showing the displacement and the factor of safety. And then you can see here, this is our final design. And then we print them out by the SLS, selective laser sintering, by using the materials carbon fiber. So we print out this it's a sample, and then it's pretty light, and then we save, I think, almost 85% reduce of the the 85% reduction of the weight, total weight for this project. So the second, the large area is the smart manufacturing. That's the one I mentioned like 3 years ago. We got this grant, and then from DOE, Department of Energy, for the clean energy smart manufacturing. So I mentioned the American mix, right? So in the US, after 2008, because of the economic crisis in 2008, and then US economy crash. So the US government, Obama, President Obama, the administration, they just initiated the trying to bring the manufacturing back to the US, and also they trying to enhance or put, make US lead in the manufacturing. So they got the US manufacturing USA established the 14 Manufacturing Innovation Institute, and American Mix is one of them. And here the SESME, I'm working on 2 of them. One is SESME, the Clean Energy Smart Manufacturing Innovation Institute, because I've been working on the energy efficiency life cycle. So another reason is this headquarters in the UCLA is only 20 minutes drive away from our campus. So we joined as a member, working with them. Another one is remade, is reducing embodied energy and decreasing emission. So this is my area, like recycling, reuse, sustainable manufacturing. So I'm working with these 2 institutes now. So they also have different institute, like in the robotics, in the fabricates, this is 3D printing, this photonics, and the biofabrication, digital manufacturing as well, lightweight innovation, and pharmaceutical as well. This is for the pharmaceutical, biopharmaceutical. So this is the project I'm working now. So the Smart Connected Worker project. Like here, this is the one of my lab. I have 2 labs. This is the one, the lab. We have the assembly line, robotics. Here, this side is the cell culture facility, like a biohood incubator. And here's some of the 3D printers I placed over here. This is the freezer, and then all the other remaining 3D printer in another lab. So we use this lab as a use case for the smart connected worker, and for the 3D printing use case, robotics use case, and assembly line, these three. And here's our schematic framework, right? We use different sensors like IoT device, like the cameras, 3 cameras, and the smart meter. And then we collect the data, we collect the frame, and then we process. We use the YOLO object detection machine learning algorithm then to detect the options. So here is a short video showing this. In the meanwhile, we can show this energy consumption, monitoring the energy consumption, and this monitoring the whole space. So next one, you can see here's our machine learning model we developed, because we need we install 1 camera inside of the 3D printer, and then we're trying monitoring the motions inside. So here is we target these 3 objects: the extruder, the build plate, and the axis. And we're trying to use the machine learning, the YOLO object detection technology to identify these actions, and then linked to our energy profile, because, and then we can see, because our objective is for DOE, we want to reduce like 30% of energy consumptions for the small medium-sized manufacturing companies. And then the way is we have to figure out how much energy they consume, right? Previously, like 5 years ago, when I was working on the project, we just used the meter to measure the energy consumption, but we can only know the energy consumption for the whole machine or for the whole facility. Now it's the new technology, the energy disaggregation. Disaggregation is we can, even same thing, we still have 1 smart meter, but through the machine learning algorithm, and we can tell which machine is on, which machine is off, or which machine is standby mode. And in the manufacturing side, we can also tell you more state, like it's a running process, and then the moving, the extruder is moving, or the heater is heating, the build plate is moving. So we can have a better idea or a comprehensive understanding of the energy consumption for the whole manufacturing system. So that's our purpose. And then we use the motion captures, and then eventually we found okay, this one converge, and also we use the pixel inch projection too, because from the wheel, the X, Y, Z coordinates is different. So we're trying to, the convert or transform the dimension and the coordinates from your view into the real 3D coordinates. So this is the work we have done. And this is the first version of the GUI. We are working on the second version. We put it online. It's web-based, so every user, they can log in, and then they can look at all the real-time, the image of each machine, and then we can tell from this machine learning algorithm, we can tell the current state, machine state. We divide it into 10, like a testing, the self-modification, the print support, preparing the temperature, and then we also show the energy consumption. But this one is small. The second version, we can tell you the more details for each channel of your electricity and each circuit. So there is more advanced. So this is the short video what we did, for the monitoring system, enable capturing, and then you can see I'm operating this 3D printer in the camera 3, right? And the camera 1 is a wearable device, and then they are looking at this operation, your finger gesture. So right now we are also working on the machine learning algorithm to identify the finger gesture and the text in the panel, in the display. So there's another camera inside to monitoring the machine. And here is the one, how we'll tell, like these objects are moving, right? And then we can tell these states, like which state they are in now. So next, I think I'm going to share with you all it's the education. The third section is a senior design project. After I joined CSUN, I have been supervising the senior design class or the project for almost 5 years, starting from 2014 to I think 4 years to 18. Because the senior, as your chair Ferry mentioned, senior design project is the most important project in the US. Every university who has the engineer program, they really emphasize a lot of efforts, put the money and the fund as well, to support the student to finish the project. Because senior design project is 1 year, we call it capstone projects, not one semester, it's a whole year projects. And the student have to design, typically primarily design in the first semester, and then make the products in the second semester, and then participate in different competitions, the nationwide, and then from the university level. So here I'm going to share all these different projects I have done. I think later on in the Q&A sections, if you want, I can share more of my experience supervising this senior design project. This is the first senior design project. Typically for our department, we have around 30 students. And then for each project, we will have 5 to 8 students. Like for this project, we have 7 students working on the hybrid layered manufacturing 3D printer. The idea is they have a traditional 3D printer and also the mill tool. So this have a mill tool. After we build the object, because typically if you are familiar with 3D printing, the surface is really rough, right? So we use the mill tool to get a better surface finish. So this idea right now, I think there's a really famous company in Japan. It's a Japanese manufacturing company, Marie CNC. They are the #1 companies in the worldwide for the CNC machining. But right now they also build the hybrid metals system is with CNC machining and metal 3D printing. So they build the object firstly, and then they will use the mill tool CNC machining center, right, to mill the surface. So this is an idea, adopted from here. This is the 2014, the student won the first prize. And this is another senior design project in 2016, the second year. And then the student developed this cloud ponics, we call it cloud system. So they developed this local panel, and also they developed the web system. All the data, we have the sensors from the fish tank and this agriculture, the container, right? We grow all these different plants, and then we collect the oxygen, and then we'll be putting into the fishing tank. The waste from the fishing tank will be put back into the upper level, for the plants to grow. So this is the ecosystem. And then all the data, we have the sensors as well to test the oxygen level, to test the water level, and we collect all these data to be displayed in your local panel and your website. There's a cloud system website as well. So this one also won the grand prize for this competition. It's the nationwide competition. It's the third year, that we have a large group. We have the collaborations between. So let me see, these students and these 2 students, they are from computer science. So this is the senior design. I started working with other engineering discipline or majors, because we work on this robotics system. We call it the vision assisted robotic arm. So we have the vision system to detect the objects, and then move so this robotic arm will move automatically to that object, and then like a screw and nuts, and then do the work, grab and then tight. So this one will also won the grand prize in 2017. And another project, this group, they got the third prize, and then the leader of this Anna is the leader for this large group of manufacturing system engineer major and engineering management, and with the computer science students, so working together. And then she also won the leadership in manufacturing award. This is for individual, and this grand prize is for the whole group. So these are some other, the senior design projects on the fourth year in 2018. The 3D bioprinter, the digital light projection is invented by these 5 students. The most impressive, this one is we got the RIS fund, almost $25,000 US dollars from the local industry and from the university. Because this DLP system is made by TI Texas Instrument, so it's really expensive. It's almost $22,000. And then another things we did raise up the fundraise, I think $3,000. So this is right now we're using this 3D bioprinter for our research. So these are some other senior design projects in the past 5 years. I supervise, like this is dynamic lag range. This is the electric bicycle, the garden boat. This is a helicopter to deliver the package. And this is a home health system. They also is the cloud system. They monitoring the, especially for the senior person, all the diabetes, the heart rate, and then send this data simultaneously to the doctor or to your app. We also develop an app. And then this is the knee scooter, designed for the senior person and the people with disability. So these are the senior design. Next, I think I'm going to share some outreach activities, because in the US, we also need, get some, reach out to the local high schools and the 2-year community colleges, because they are our feeder. So all the students, most of them is from the local high schools or the community colleges. So we also need to do a lot of the outreach activities. So here is, I bring my students. This is for the NSF, the grants. We had a field trip to visit the Strassys company. Strassys company is I think the second largest company in the worldwide for 3D printing. So these are their demos, and for different product, you can see from large scale, from Eiffel Tower in Paris, they build a scaled model, and then this is self-assembly products. This one is the real functional parts they made for the one local company, for their vehicle, for cars. And this is tools they made for the self assembly. These are also different, the parts they make. They also make one shoes for Nike, for the local. And they also have these different tools, also colorful, the object. And then this is the colorful object and the candy as well. So this is my group of students. We visit this company, Strassys company. And we also visit another company, is a metal 3D printing company, is a Morph 3D, 2 years ago, I think. This company was a new startup company, but they made all the parts for Boeing, SpaceX, for Raytheon, for Grumman, Northridge, and then Lockheed Martin. So for different application, you can see this complex geometry right now is for metal 3D printing. They can make amazing, complex geometries by these mechanical parts. Most of them is these are just for demo, but these two are real mechanical function parts. They are used in the industry, in the aerospace. And they also have a large part of project for the lightweight design as well. Like this one is for NASA. They redesigned this part for these two parts are both for the satellite. They saved over, like this is 79%. This saved I think 85%, I think, for this part. So that's the new, the technologies. And then I also bring a group of my students with this company. And here is another CCPT grant outreach program. I host the Saturday Academy in digital manufacturing for the local high school students. And students just come to, in Saturday, and then they can take the class in 3D printing, the SolidWorks, and then after 12 weeks, and then we give them the certificate. So, but after that, after this project and this grant, and then we converted it as the regular class in the local community college. It's the 3D printing, the modeling, and the offers for both college students and the high school students. So these are some other, like funded for AIM Square. This is a student from local community college, not the CSUN's bachelor students. So here's some other, the outreach activities I have done in the past few years. And yeah, this is the event, because I'm also the faculty advisor for SME, it's the Society of Manufacturing Engineer. I think that's all for my presentation. I hope, okay, I used 40 minutes, very sorry.
Okay, that's fine, that's fine. So
yeah, and then, yeah, we can start our Q&A sections, and then I'm more than happy to discuss and share any ideas, and then answer any of your questions. So I hope we can have a fruitful, the discussion and the Q&A section.
Okay, Professor Bingbing. Before we start the Q&A, so I am recording this meeting. Okay, is it, that's okay, right?
Yeah, sure, no problem.
Okay. So that's right. So I think before we start the Q&A to all the participants, we can see what they are doing there in the US. So here we are talking about Industrial Revolution 4.0, and see what they are doing. That is Industrial Revolution 4.0. They use all the technologies. They use computer. They use 3D printing. They use 3D printing. They use a robot. So here, when we are just talking about Industrial Revolution 4.0, but see what they are doing over there. They are doing it in research, in education, and also in outreach program. So in his last part of the presentation, the outreach program here with us, it is a kind of a community development. But for Professor Bingbing, his community development is more to the high school, to encourage the high school student to participate in engineering project, to be an engineer. That's what he is doing, right, Bingbing? With the outreach program. So that's the motivation, right? To attract the high school student when they want to go to the university, so that they're gonna join engineering school. Is that correct?
Yes, I think the U.S. Education system is unique. Like when I was in China, like for high school student, we just learn like academic and then taking courses. That's it. But in the U.S., like for the NSF, for different, the federal agency like NSF, DOD, DOE, NASA, right? They have a large component for your fund is you have to have a detailed plan for the K-12 education engagement. That means the federal agency will give you money so you can get these high school students involved in your lab. Like for my research lab, I always have like a high school research internship position. Yeah, they become like once a week working in my lab for 2 to 3 hours with my students, and then eventually they will be exposed to the research project in the college. Yeah.
So when those agencies give you money, so they don't want you to just do research, right? They also want you to serve the community by using the outreach program. Okay.
Yes, to pay back, like this is a return to the community.
Okay. So as an overview, so Bingbing mentioned several agencies, the NSF, that is the National Science Foundation. It is a kind of what here in Indonesia, it is like Dikti maybe. So that's the same agency that give money to the university to do research. And then DOD, that is the Department of Defense, right, Bingbing?
Yes, DOD is
Okay.
the Department
of Defense.
Defense.
And NASA, I think everyone know what NASA is. And also we also hear from you several private company, Harley Davidson, and other manufacturing companies that involve.
Yeah, and then another one would be the DOE, is the Department of Energy, because since we are working in the energy area in like life cycle assessment, energy efficiency, yeah, DOE is the major sponsor, you know, for the energy related project or funds, like for global warming challenge, right?
Okay.
The climate change.
Okay, so and also with the senior design project, we can see that every student produce something. It is not just a report like what we have here in Indonesia. We ask students to do research and then report the result of the research, but that is not the case in the US. They need to have a real product. That is right, Bingbing?
Yeah, exactly. Yeah, I think there's also like, since I was from China, right? I was born and raised in China originally. Like, yeah, I think maybe the China's education is similar to Indonesia. Like, when I was the senior students in the bachelor degree, yeah, the only one semester senior project, and then we just write the report, and then that's it. We don't have to make the products or make something. Yeah, go ahead, Ferry. Sorry to interrupt you.
Hello, Bingbing, can you hear me?
Yes, yeah.
Okay. Halo Bapak Ibu semua, bisa dengar suara saya?
Bisa Pak Ferry?
Bisa.
Okay, ayo. Okay. I think that is it for the overview. I think it is because of my internet connection, so I'm facing a problem right now, but I think it is okay right now. So I think we have several questions from the chat window, but before I go to the chat window, before we go to the question from the chat window, I am asking, I'm calling the participant to ask Bingbing directly. Anyone who want to ask Professor Bingbing directly by activating your microphone and your video. Anyone?
Yeah, you are welcome to speak up and then talk to me directly.
Halo?
Halo.
Halo? Siapa ini?
I am Ojo Kurdi from Diponegoro University.
Okay, okay, Pak Ojo Kurdi, he is from Diponegoro University. Please directly ask your question to Professor Bingbing.
I just want to ask regarding the manufacturing cost of one product. If we fabricate using the additive manufacturing or 3D printing, compared to fabricate with the conventional manufacturing, which one is cheaper?
Yeah, I think this is a pretty good question. Like, this is always the first question the student will ask in the first class, because I got the NSF grant, and then we developed the 3D printing class for the undergraduate students, so the student, both under and master student, they can take. Yeah, this is always the first question. Like, let me answer this way. Depends. It's pretty interesting. The question, like, every new technology invented, right? They will have a period of time to convert. Like, you are the IE students, right? I think you have learned the curve of cost. Yeah. But now is for the 3D printing technology. Like 10 years ago, when I first, got exposed to the 3D printing, at that time it's pretty expensive. And then now the 3D printing materials, like a filament materials, is getting cheaper and cheaper. Like if you get the materials and 3D printers in China, is more even cheaper than the US. Like every summer I will go back and visit China. Like the filaments and the 3D printer over here in the US, a lot of high school students, they purchase the 3D printer kit. It's only $300 or $200 US bucks. and then you can get the desktop 3D printer. It's pretty cheap. So this is from the trend of the 3D printing. You can see the cost. I believe the cost of 3D printing will be going down in the next another 10 years significantly. I mean,
Significant.
so the materials, and so this is the first perspective. The second perspective is, even for now, I think maybe you are not familiar with like aerospace industry or the defense industry. Like for aerospace and defense industry, I think we can compare like a normal industry, a lot of consumer products. We can use injection molding, and then we can use milling, drilling, right? Like in China, there are lots of manufacturing facilities. And then for piece of this like a pencil, right? And then we can, the cost is only maybe 7 cents or certain cents,
very cheap,
right? It's really cheap. But for 3D printing, to be honest, if you print them in the FDM, the most cost-effective technology, FDM, that will take like, I think like $50 US dollars to print it,
Yes.
including the cost and labor, and then will be $1. So it's not cost effective, but this is for traditional like mass production. But if we go back to the aerospace,
Yes.
defense, and some like a personal, highly personal, you know, customer to industry like medical, right?
Yeah.
Medical implant and the dentist.
Yes.
So for dentist, every dental dentist, they will get the mold of your teeth, and then they will make. And for defense area, you know, the reason why we're working for Harley Davidson is, you know, right now their current, you know, the cost to make this cam support is relatively cheap. If you only consider this component itself, they can use using the CNC machining, and then they will be cheap. But this is for mass production. But if you want to make a new generation of the products, they have to, and then you have to consider the life cycle of the cost, including the fixture, right? Each hole they have to design, and then different fixture and the tools, and then the total lead time. Because I talked to Harley Davidson, and then the reason why they want to use the 3D printing for the prototyping and the new design of their product is the total lead time will be reduced significantly. Because for the CNC machining process, they will take, I think, 9 months to design their molds and the tools and the fixture,
Yes.
right, for that cam support. And there are also a lot of different procedures. But for metal 3D printing, of course, each part will take, I think the part I showed you in the slides that took, for, let me see, 32 hours to finish the print. It's slow.
32
Yeah, 32 hours. It's slow. But, you know, after that, we use, including the pre-processing, post-processing, overall, we can make it this one within 1 month. So 1 month compared to your 9 months, you know, the lead time, that's a significant reduction. This will make more sense for NASA, for aerospace, and for defense. Because like for aerospace, if you take the example for aerospace, the part typically itself is really huge, and they don't need the mass production. For Boeing, there's no mass production for them, right? They only make maybe 20 or 30 maximum airplanes per year. And for each airplane, they make the engine is unique. And then, you know, for each of them, they will cost a lot of, you know, the time and the cost as well. Yes. But, you know, for the project I show you in the Morph 3D is the supplier for the Boeing SpaceX company. For each part itself, I think even though it's, I think like $42,000, but compared to the cost they purchase from the traditional manufacturing, right? They have to pay more. You know what I'm saying? So depends on which industry. Like for consumer, like this pen or this, you know, the desktop or this iPhone, right? Of course, definitely we will use mass production, and then it's way cheaper. But for some customer like market, the dental, medical, defense, aerospace, right? Or the prototyping, and then that will save a lot of money.
Okay, thank
Did
you.
I answer your question?
Yes.
Okay.
But I want to know about the issue of the strength of the product that's produced by the additive manufacturing compared to the machining process. Maybe is it okay, because you mentioned the defense field, and also for the Boeing maybe, and for the aerospace, this is need the high safety, how about the regarding the strength or durability of the product resulting from the additive manufacturing? Is it quite okay?
Yeah, actually, yeah, this is a pretty good question. Thank you. Yeah, thank you to raise up this question. This is a really hot topic, research topic now in the US, like especially like 2 years ago, I also got a grant. We're working now with UCLA on the material science. Yeah, there are a lot of discussions for the quality control of metal 3D printing. Like a metal 3D printing, whether we can achieve the same quality or higher quality compared to the traditional like a CNC machining, right? The answer right now is after the first initial years, no. Because I think 3 years ago, only Honeywell got a certificate from DOD. Like their parts will be used for airplane, for the defense on the airspace. All the others, they failed. But now more and more products, they got the certificate, get approval from the Department of Defense. Like they are ready to go to be applied in the real airplane. The reason why is, the metal 3D printing technology itself was the revolved in the past maybe 5 years, but it's that's starting from like 10 years ago, right? The technology itself is almost like in 1987 something. It was invented by the professor from UT Austin, but that got boomed. The technology got boomed 10 years ago because of laser technology. The laser technology was matured, especially in Germany. So now is, with more advanced laser technology, we can get the really tiny, like right now there are resolution can going down to 20 micron. And these laser, they can melt these metal powders, combine them. So a lot of the research was working now on the crystal structure of these metal powders, right? Because we can see, for the traditional manufacturing, typically for all the mechanical parts was made by casting, right? Casting and then use milling and drilling to get the final product. But casting, they also have this critical issue is the cooling and the heating, the cooling rate, right? They have different rates from the whole part, especially for the large part, that will have more chance of deformation or the defects, right? But the 3D printing is they just work on the small scale, like they combine the 20 micron metal powders with nanoparticles as well. Right now, we put a lot of nanoparticles and composite into the metal powder. And then they improve these mechanical properties a lot. So now, right now, the quality of metal 3D printing is much better than like 5 years ago. That's why now more and more, the mechanical parts, they got the certificate and approval from the DOD, and then they are ready to use, because these are the critical parts. Otherwise, if you don't meet these, the higher standard, right? You cannot use them, in the airplane or in the defense. Not like a toy, right? That doesn't matter if it cracks. That's it. We just throw it out, and then we can get a new one, right?
Okay.
Okay, thank you very much.
Okay. I think that's. I think that is it from Pak Kurdi from Diponegoro University. If I can add something, I think originally the 3D printing technology coming from NASA, right? So it is very high cost if they just if they use a rocket to bring a component for the International Space Station, right? And they have an idea how if we just manufacture that product in the International Space Station, and then they use 3D printing. So that's I think the original idea of using the 3D printing. So Professor Bingbing is as what Professor Bingbing mentioned to us, that the 3D printing technology is mostly used for the customized product, for the special product. It is not for mass production, not yet. I think that's what I can add.
Okay, thank you, Dr. Ferry.
Okay.
Yeah, I can add one more, the input comment. Like right now in the Europe and the US, more and more company, they also consider this one as mass production, but it's not like 10,000 something, right? But it's relative more. Like the structures we visited, right, is they have 30 same machines producing different product all the day, 24 hours, 7 days. And also Honeywell, I visited Honeywell is the aerospace company, the largest company in the US. They built a metal additive manufacturing division in Arizona, Phoenix in Arizona. They purchased the 300 US, the metal 3D printer from Germany, and then they build the aerospace parts now. So this is kind of mass production for aerospace industry, right? Because they are not going to make like over 10,000, 100,000 parts per year, because there is like 1,000 per year or less than that. So, but it's kind of, after they get the new technology certified by the DoD, and then they are going to the next phase is mass production. They just purchase like 300 machines and then produce them.
Okay. I think I hear a voice of a woman.
Yes.
I think she wants to ask question, and who is that?
Yes, thank you, Professor Bingbing, and thank you, Dr. Ferry. And actually, I'm the one of the alumnus of Andalus University from Industrial Engineering, and I want to ask about two questions. But my first question is has the ask from Sir Kurdi and has the answer. But I was interesting about the project of the student with the practice and make the product real because I have done already about the project like that. We call it practice on the workshop. Today I use the material polyurethane. Maybe Professor Bingbing aware about the material polyurethane, PU, PA, and we using that material in the latte machine, milling machine, and drilling machine. But I have one problem issue that if we use the PE for the workshop, our workshop, that latte machine, milling machine, and drilling machine, the material is something like become frackless and
the brittle, yeah,
brittle like that, because the PE is not suitable for the high heat, high temperature. So I was interested about the 3D printing technology, but I want to ask about how we get the material or the resource of material. If I want to make I want to make a customized surface to produce the 3D printing product, how we get the material and what is the type of material we can use for the 3D printing technology like that, because I have the experience using PE material, polyurethane.
Okay.
Yeah.
I think the question is very clear. Okay.
Yes. Yeah. Thank you so much. Yeah. This is a good question. Like different materials, like you use PE, right? For the 3D printing right now, like when 6 years ago, when I first, start working on the research project, at that time, only like ABS, PLA, nylon for this plastic, and then it's popular. And metal is only stainless steel and nickel. So 6 years ago, that's popular in the US. But for other materials, really expensive. Oh, we didn't see the product. But now, like last year and last month, we attended a different conference, the professional exhibit, right? They have more materials than before. The material science, because in the 3D printing area, there are different areas. The first one is innovated, new process, right? Still now they have more and more, the new process coming up, and new startup company coming up in the US. So this process like FDM, SLA, and SLS, the powder bed fusion, right? And the second one actually is fundamentally is the materials, the one you just raised up, material science. Material science itself that has developed really rapidly in the past 5 years. PE is the products, the 6 years ago has not been bad, but right now I saw the Strass's company, and then they sent me some samples as well. PE has been, the really good materials, mature materials for the FDM, fused deposition modeling, right? So, and more, I also get the nylon and the soft material as well. Like in the presentation, you see these different colorful, the prints that's made by resins, and the the other thermoplastic, the materials made by SLA, stereolithography lithography technology, and the jetting as well. So these new different technology, new process make it possible to make like a PE. Like even for aluminum, same thing. Aluminum, there's a 771. 771 is non it's non-jointable, by the traditional manufacturing. But now we add the new nanoparticles, improve the mechanical properties, and make it possible. And then also go back to your answers, how or where to get these materials. I don't know. I'm not familiar with the Indonesian market, right? So in the US and in China, I know, like in the US, most of the materials we purchase, either we also purchase from like a Strassys, this vendor, right? They sell the materials, and we also get some new materials is in the university lab. It's R&D. It's still under R&D process, but we just use them. Like the one you mentioned, the PE process, PE materials, right? Because the PE material itself is brittle, right? So it's really easy to be fractional. So it's not, their elasticity is not good, right? So, but now it's, I think I saw some papers most recently, they add some nanoparticles into like a PE or the PVC materials, like PE and PVC, these materials, they're brittle, plastic. So they improve these mechanical properties, because nanotechnology also play a role in the material science for 3D printing. So we can change the different formula of the plastic by adding the nanoparticles, carbon fiber or nanocomposite to improve the mechanical property. So we also make them possible as well. Okay. But I don't, like, if you ask whether the student, if they want to do the real projects in practice, whether we can get these materials, that's I don't know, to be honest. I don't know whether it's available in Indonesia's market or not. So okay, yeah. But now this is the trend. Like I think even for you are the largest, the public university in Padang, right? So you can also collaborate with other like a material science department, working on something, test these different materials, right? And then either work on the process or materials. Okay. Yeah, that would be a really good research topic. Okay.
Okay.
Yeah. Okay,
Okay, thank
thank
you.
thank you. Okay, thank you.
Professor
Thank you.
Bimbing.
Thank you.
From
Bu.
Northridge.
Okay, thank
Thank
you.
you.
From Putra Batam University. Thank
Okay,
you.
thank you so much. I think yeah, I don't know how to get those materials in Indonesian market, but with the online shopping right now, I think it is we can order those
Oh,
materials
yeah.
online. We can order those material
Yeah.
online, but the vendor may be from overseas, right? We can just order them. I think from Amazon. Can we order the materials from Amazon? I don't know,
Yes, yeah.
but yeah, because when I was in the US,
that's a good supply chain question, right? That's a
yeah.
typical area for
Yeah.
IE students. Yeah.
Yeah. Okay. Thank you, Professor Bimbing and Bu Nofri. And then I'm gonna go now to the question from the chat session, from the chat window, Professor Bimbing. So we have a question from Lucy Susanti. Okay. So this is regarding the education part of your presentation. So she asks you, for the senior design project, do all the students in the project coming from the IE, or do they collaborate with other students from other departments? How many students in a project? Who and how to distribute the project to all the project members? Then how you gonna assess the project?
Yeah, I think this is a perfect question. Suppose this is from professor, right?
Yes.
Yeah. Okay, yeah. As I mentioned before, okay, do all students in the project come from IE department? The answer is yeah, like I mentioned, because when I came here into a couple of years, 6 years ago, I'm inexperienced, but this is the trend. So I collab with other, faculty members as well, but I didn't collaborate a lot. But what we did is, but starting from the third year, and we collab with computer science department within our university, and now then I collab with EE student as well. So you can see in the slides, there's one project done by student from manufacturing system engineer major, and from engineering management, and from computer science. This is one of the project. I also have some other project the students get from student from art design as well. Art design, because they have a better idea for the visual design. They can design really beautiful and perfect, the outside. Sorry, my daughter just came here to trying to disturbing. Okay, 去找妈妈啊. Okay, so and also right now in the US, there's another trend is more and more university, like Stanford University is the first university to get the multidisciplinary D school. They call it D school. It's a design school. They recruited different faculties from engineer, like computer science, mechanical, EE, civil, and then also from other department, from like theater, from art design, from social, even from social design, social science department. And then they establish this school. So any student who is interested to work on the senior design projects in this school, and then they develop this mechanism, this formula, so they can take the senior design over there, and then any student, they can join the group of students. So they will have a faculty advisor to that specific project. They will have call for project in the summer before the senior year, the fourth year. And then they will assign this project to from different background, and then they will group. But typically the size of these projects, like from 5 to 6 or 8, sorry, from 5 to 8 students from different major, from different background. So that's because that's almost 5 years when I visited Stanford University. I stayed there for 3 days. We have a program, so we learned a lot from that one. So that model right now has been applied broadly in the US, like UC San Diego, more and more university, they have a maker, we call it maker space. and the design school. Design school is a multidisciplinary school across the university, right? Cross the, we call it the converge research or multidisciplinary senior design projects. So if we come back to CSUN over here, we also have the mechanism. So the only thing I know, like I also gave this talk to China, to my university I graduated. They also have the challenge how make these students to take, you know, the cross-disciplinary senior design projects, because it's difficult, especially in China. Same thing. But over here is what I did in the first couple of years before is a policy. Now is I just talked to the professor, for example, from computer science, who is also supervising the senior design project, or the professor from EE project, EE department. We have the agreements because every students in different department, they have to take a senior design. And then they take 3 units of class for each semester. Totally is, I think, 6 units. So anyway, they have to take, they got this 6 units for the senior design, as long as the, you know, faculty agree to give the credit to the student, and then we will assign the students to work on the, you know, the like 2 students from computer science, 3 students from mechanical engineer or IE, right? They work together. We got approval from the faculty. We don't have to get approval from department chair. We have this flexibility in the US, as long as the, you know, the I agree, you work on the projects, and then eventually you report, and then report to me and also to the professor from computer science, and then eventually I will give you the credit. I will give you the grade. So that's the thing we did 3 years ago. But now CSUN already have a mechanism. So any student they want to work on the multidisciplinary project, that's fine. They can just join that project. So the college have a associate dean. They have an initiative, right? They will have an announcement for this type of projects in the summer of before their last year. And then any students are interested, right, from the whole college, because our college have 5 departments: department of computer science, mechanical engineer, civil engineer, manufacturing engineer, and engineer management, and civil engineer, right? So any student interested, they can supply their application to this project, and then they will have a screening process, and then student will work on. So that's the current mechanism we have now on campus. But I know that there are some challenges, right, especially cross department. But since you have the support from the department chair, like he's pretty open. I know he's an open man. So I think you can work with other department and then come up with a plan. Even you can get the agreement, you know, across the department, but you can talk to the faculty. As long as the faculty agree, eventually you still give the grade, right? A, B, or C, whatever. But the students, they just did their project. And the last question, I think, is how to access their process. Yeah, typically for my for our department, the size is from 5 to 8. But for mechanical engineer and the civil engineer, I know their senior design project is really large. Because for mechanical engineer, some students, they work on the formula SAE. So they will have like 30 students, because they also have the ME student, department have a large population of students compared to the IE or the engineer managing or manufacturing. So they have like 30 students for formula SAE, but for our department, you only have like 6 or 4, depends. For computer science and EE, I know its average size is like 5 to 8. But civil engineer, because there's also, they have a special program, like typically they have to build a canal or the bridge, right? So they also have a large size, like 15 to 20 students to work on the one single project. And the projects typically I will assign, we have the group we have weekly meeting every week. I will check their progress. And I will give them a grade based on their weekly, we have the weekly report, bi-weekly report. And another one is we call it CDR and PDR. PDRs, we have 2 PDR every 1.5 months. PDR means preliminary design review. CDR means a critical design review. It's the end of semester, we will have the CDR to review the students' project, presentation, and their real product. And also we have another, let me see, rubric to assess the student performance. And I know like the faculty always have challenges. If you have a large group of students, how can you make sure every student will engage or contribute, right? So we have a peer review form rubric. So every student will have to assess their partner or the group members' performance every 2 weeks, or and then eventually also have in the end of the semester. So their final grade will be based on for example, the whole group get 80 out of 100, right? And then for each individual member, depends on their peer review evaluation. If they only contribute like 20%, 30% based on the evaluation from other group members, and then his final grade will be 20% times this 80%, so only like 16%, right, or something like that. So I think this is fair to the students. So we just run this way for the senior design.
Okay. I think I want to add something to the question, Professor Bingbing. So,
Sure.
Are there groups that are only the member of the group only coming from IE students, from the IE department? So they don't collaborate. So in one group A, for example, all members in that group are industrial engineering students. Do you have that kind of case? No. Okay.
Yeah, we do.
Okay.
Yeah, we do have like some group of students. All the members in that group is from the same major. Yes, we do.
Okay. Now,
but they still work on different perspective of the project, like mechanical, electronical, because they have designed the structure. They also need to work on the electronics, right, and the programming, the wiring as well. Like I already showed some of the project picture, right? It's not just mechanical function parts. It's also programming, cloud, the web-based app they have to develop. So they have to get all these different perspectives, even though all the students from the same major.
So in the case of the IE students, can they handle that? Can they handle the wiring, the electronic work, the programming, the structural design? Because we know that from the IE perspective, we don't have a strong background on those things, right? So how the students complete the projects if they need to do wiring, electronic work, programming, and so on and so forth? How?
Yeah, so that's why I think that's unique in the US is like even for the first year, the hybrid 3D printers, all the students, they are from the same department, same major, and they have to develop the G code and then the wiring. They have to design the board as well. What they learn is typically the faculty will provide the supervision. If the faculty is not expert in the like electronics, right, or in the software development, and then what I did is I will get help from the computer science, from the EE department, and direct them, because I have some, the friends in the, at least like one member from that department, right? And then I will ask them to get help from them and then supervise how to do that. Another way is some students in the US, they are a lot of self-motivated. They will learn, they will work really hard on that section. They learn by themselves and then ask their friends in other departments. So there are two ways. One is from the faculty perspective, typically the faculty will be dedicated themselves, trying to help them as much as possible. right? You share the resources from the university, from department, from college, right? And make sure the student can success. But this one is it works like most of the time. But the most important thing I think is has to be relying on the student themselves. So the students will be self-motivated, and then they will learn a lot, work really hard. Otherwise, if the student doesn't have an interest or the the motivation, if you push really hard, and still you didn't get really good results. So that's why for my project, senior design project, every year I have like 3 to 5 projects, but the most I have won the grand prize of every competition every year, just because I use a lot of them, push them, and then some student they are the one who got the grand prize is always that group of students is self-motivated students.
Okay. That's another thing for me is that how if the project fail, so the prototype doesn't work. So
oh yeah, that's a good question.
Yeah,
that happened once in the first year I came here in 2014 and 15 academic year. A group of students, I pushed really hard, and then because these are the international students from Saudi Arabia, they don't care. Like, I don't know why. I talked to them a lot and then push them, really hard. But they are sponsored by the Saudi Arabia government, and then they don't worry about the money or the tuition, so they just don't care. So eventually, at the end of the year, I check their progress, because the most important thing, you have to make the product work. So for that group of students, I feel them.
okay.
I give F to them, and then I said, okay, so this is unacceptable. So if you want to graduate, and then you have, so what I did is I give them extension. They have to come back to work on that project during the summertime, and then make it accomplish. And then I change their grade, because in the US we can give the grade initially and give some extension, and then we will change the grade for the student later.
Okay.
So that's these students, they did feel in the senior design.
Okay. Good. Uh, uh, Again, from me, what about the money? So the student fund their project themselves, or they get money from the university, or they get sponsored?
Yeah, that's a good question. Most of the time, I think the university, first of all the university in the US, I think they have a special fund. They have allocated a fund to the senior design project. Like for our department, we have $6,000 per year for our senior design project. Yeah, and besides that, the student, because the $6,000 is not that much. Like we have 4 or 5 projects, and for each project we only have maybe around $1,000, because $1,000 you have to purchase a lot of materials, electronics, so that it's not enough. So but in our department, if this $1,000 for each project is not enough, right? This one was funded by the department, by the general fund from the university. And then there's another available fund in the university. We call it the CQF. It's a campus quality fund. So that each student, they can apply, because this fund is from students themselves. They call it associated students. They have the fee. Every student will pay $50 per year. So they will allocate all the $50 of student to the associate students organization. Like a lot of student club organization was managed by the AS. So they also have a special allocated fund for student project. So if you don't have enough money for your senior design project, you can apply. And then each student can get up to, I think, $200. But for our project, we will have 6 students. We will get like 120 something. So I think typically that would be good enough. And then that's the fund from the university. And then we also have the funds from industry sponsor. like in the US, like in the tier 1 research or more famous university like Stanford, UCLA, MIT, Harvard, right? These universities, they have, most of them is from industry partner. They sponsor their senior design project and then like $2,000, $3,000 per year, something like that. And also there is another way is like the one I mentioned for the 3D bioprinter DLP project we did 2 years ago. That one is, you know, these 3 students, they are from Saudi Arabia and Kuwait. So they raised like a lot of money, like $10,000 US dollars from the private company in their home country. And another 2 students, local students, they got another 5,000 sponsorship from the fundraise from the local company. Yeah. So this is another source of the fund is, but this one is it's not that easy because you have to reach out to the local company or international company and then get the fundraise. Yeah. But the primarily is deep, most of them is from like university general funds, and if they have a sponsorship from the industry, like a lot of universities have a long-term, you know, sponsorship from the industry.
Okay.
Because in the US, like I think that's the difference with China, because China, I don't know, maybe it's similar to Indonesia. Like in the US, there's if you, most of the company, they have to donate something to the community to avoid the tax, because in the US, the tax rate is really high for the company. So anyway, they have to donate something, you know, to whatever like organization or the yeah.
So, but their motivation, the mainly because they want to avoid tax.
Yes, yeah, because the tax.
It is not. Yeah. It is not just giving money to the university, but they have something else to avoid tax. But
yeah,
that's a good thing.
But
that's
yeah,
a good thing for the
some
university.
industries, they have the vision, and then they are really generous to donate as well.
Okay, thank you, Bingbing. I will continue with a question from the chat. So we have Andy Rahman right now. He is a student. So we agree that the technology, the 3D printing is very helpful. Now and in the future, it will be very helpful. So according to you, Professor Bingbing, what is the main strategies to support this technology? Because the technology is still quite expensive. So what is the strategy to make this technology, maybe to use this technology in mass production, maybe? So
yeah, I think this is a challenge question, like to the government. Yeah. Let me try to answer this way. Like, I think the strategies to support this technology or any new technology, I think based on my understanding or my experience, first of all, it has to be supported by the government from the long-term view, like by your government, like a federal agency, like US, it has to be funded by the DoD and NSF, NASA. Otherwise, there's no way to work on this new technology in the R&D, right? Like that's why, you know, in the worldwide, if you look at different countries, like the development country, right, they did a really good job in the new research and technology just because has been funded and supported by the government, right? That's the first thing. I think the second is, I think that would be, you know, the support from the industry. Like a lot of technologies from the industry need and the demand, right? Because some of them we cannot solve these issues or technical issues. That's why industry will be put, because typically industry will be profit, you know, it's the profits in a private company. They are pursuing the profits and income. So they are always, you know, trying to find the solutions for them. So in this case, like the 3D printing technology, like your chair Ferry mentioned, it was initiated by like NASA, right? Is to meet the requirement from these different like industry or the government needs, or from the national security, or from the defense, you know, the purpose. So the strategies garment, and then there'll be the industry. The industry, that will be another, the good driver, to promote the 3D printing, right? And then in this case, we can have more cheaper and cheaper solutions, right? Otherwise, like university is good in the research, but it's not good in the commercialization, right? Because if without this industry engagement, the motivation, and then we cannot get cheaper technology, or we cannot get some better technology and with cheaper, price. So I think that would be driven by the large amount of investment from the government, and then that will be driven by the industry.
Okay, I think that answered the question. And now I want to come back to the audience. Anyone who wants to ask question directly by activating your microphone and video? Anyone? Oh, okay. Bingbing, with the 3D printing technology, what about the energy consumption of the technology? Because you need to heat up the metal, you need to heat up the plastic into their melting point, and then you print it. And I think that's gonna consume a lot of energy. If we compare with the traditional machining, which one is better?
Yeah, this is a complicated question. Like for I think you are familiar with the life cycle LCA, right? If because we discussed this a lot in the US, and then because we're working on these projects funded by the DOE, Department of Energy, because the DOE really concerned about the energy consumption, energy efficiency. So I think some research has been done, and the kind of conclusion is for maybe a single part, like maybe for plastic, I think it's fine. Plastic, FDM, SLA, the energy is not that intensive, right? But for metal 3D printing, because they use a high power of the laser, like 400 watts and even 1000 watts laser to melt the metal powder, it is energy intensive process. It's much higher if you compare, to manufacture the same amount of the same parts, right? By 3D printing and then by traditional like machining, right? And then of course they will take a longer time, and then also it's energy intensive. This is for a specific process or like narrowed down. But if you look at the overall, the life cycle assessment, that would change, right? Like for example, for the motorcycle engine project I mentioned, right? CNC machining, they only involve to drill or to improve the surface, drill the hole, and then remove the materials from surface, right? But if you consider from the material extraction, right, the material itself is casting. Casting, they also have consumed the energy as well, right? And to prepare the fixture, the tools, all these costs and energy has to be considered as well. So in that case, if you from the life cycle perspective, and then, but it's still hard to say, but the energy is not that, the intensive, or in some case, based on the project we are working now for the DOE, in some case, actually 3D printing saved more money and energy.
Okay.
But most of the time is worse than the traditional manufacturing.
Yeah.
At the current phase.
Yeah, I think I agree with that, because with 3D printing, you cannot produce many, right? Because it takes time, so you cannot produce many products. But with traditional, with a traditional process, you can produce many products. So when we calculate on average per unit of product that you produce, I think the traditional manufacturing process is still it is better than the 3D printing technology in terms of energy consumption, if we take on average.
Yeah, another way is you can think about this question like traditional manufacturing is a subtractive process, right? You remove the materials from the raw materials, the like in this case, a lot of waste generated. But for metal 3D printing or 3D printing, they build the products layer by layer, right?
Yes.
So it's additive. So in that case, from the process itself is more efficient. But of course, yeah, there will some process like a laser involved metal 3D printing. That's energy intensive process. It is.
Yeah. Okay. I think I'm gonna go back to the chat session, and there is a student, and her name is Rahmayanti. Oh no, Rahmayanti Dina. I think she is a professor. So for the IEs, but I think the question is for the students, from the students, from the student perspective. If we want to involve in this new technology, the 3D printing, as an IE student, what we need to learn, we need to master on what course from the perspective of an IE students. I think material science, of course, manufacturing processes, of course, but what else that we need to know if we want to focus on the 3D printing technology?
Oh yeah, to answer this question, I think I need the answer from you. Like, what's the curriculum in the IE in your department? Because I think the curriculum in the US is a little different with like IE in China, because I visited different universities. Like I think you were in Texas Tech, right? Texas Tech IE department, the curriculum is there is one manufacturing process course.
Yes.
So IE student also need to take that course is a manufacturing process.
Yes.
And in our department, same thing. Our department students is considered as IE student, but we also have one course is related to manufacturing, not the material. Yeah, we have materials. That's the 227. That's for second year of students. They have to take that one. That material engineer class is general engineer class for every students in the engineer college, like mechanical, computer science, civil, EE. Every student have to take that one. So I don't know, do you have any class in your curriculum related to manufacturing process?
Yes. We have manufacturing processes. We have material science. So even we have lab for the manufacturing processes. And then we have production systems, but with the production system, it is more to the management side of the manufacturing system. Mostly in the production system, we deal with the assembly system, the assembly line. It is not the manufacturing stuff, but it is an assembly line. But we have a 3 credits course, and that is manufacturing systems, and manufacturing processes or manufacturing technology. So that's what we have.
Okay, I got it. And then let me answer this question. I think this is a really good one. Before I got this NSF grant is funded by the IUs. IUs means improving undergraduate research, undergraduate STEM education. It's IUs, IUSE. Means improving undergraduate STEM education. So this is the NSF specific program they found to support the universities to do the curriculum development. So that's why I collab with Texas Tech and Kansas State, and then we develop a new course. It's a 400 level class for IE students. So this is, we call it the 3D printing and 3D printing and lab, this new class. But so in this case, it's a new course you can develop. There will be an elective class for IE student. So both undergraduate students and the master student, they can take this class, because in our department, master student, they can take up to 2 courses, 400 level classes, undergraduate classes. So in my class, I have both under and the master student. But if you don't have this mechanism, then what I did is, before I have this specific create a new class for 3D printing, what I did is in our department is 3 courses I think you can do. One is, I think this professor mentions how to, if we want to start a basic project about 3D printing, right? There's one class you can do is Engineer 101. Engineer 101 will be a perfect start class. You can introduce the 3D printing concepts. So you don't have to give them a lot of details about the metal 3D printing. No, just give them the, the FDM 3D printer is really cheap. Like from Amazon, I know.
Bingbing,
Yes.
Sorry to interrupt you. Engineering 101, that is an introduction to engineering, right?
Yes. I think this is a basic class for every engineer curriculum, right? I think IE, they also have engineer 101.
We have similar kind of similar one, but
because the student will be exposed to engineer topic, and then they will do some small project, right? Yeah. So in this case, you can assign or introduce the 3D printing concept. That's it, and then ask a student to do some project related to like FDM, just FDM. FDM is really easy to start and establish. Like in the US, we can purchase 3D printers, only $200, really good printer. And in the US, in China, I think in the market is only 100, converted currency is only 100 US dollars. I think this is affordable for your department. So this is one class. Second class, since I also mentioned the CAD. I don't know whether you have a CAD class in your curriculum.
Yes.
In my department, we have 200 level is SolidWorks. We teach them SolidWorks and Autodesk software. So in this class, our curriculum is we will teach the student to how to use the software, right? And also in the end, the student have to do the project. So you can use this class to ask the student to create some modeling and then print them, right? You can just add the requirement, okay, you are not going to just create a model in the SolidWorks or other software, the CAD tool. You will be, since our department have some facility like a 3D printer, right? You will be able to print them out your design. Like you can just print out some small, like even keychain, right? What I did is like a small keychain or toy. You can bring home, right? Really good and fancy. So student will enjoy. So this is the second class you can do. The third one I think is the one I mentioned, like a manufacturing process. Manufacturing process, that class is a perfect. I think in the US, a lot of professors, what they did is they modify this class a little bit because 3D printing is also one of the manufacturing process, right? So in your last, maybe take 1 or 2 lectures, maybe like 4 to 6 hours, right? You give them a brief introduction of different technology in the 3D printing, right? FDM, in this case, you can introduce more idea like FDM, SLA, metal 3D printing, 3D bioprinting. And then the student will have a better idea about the 3D printing, right? So this is because this class typically is for junior, right? So then for the senior design, they will have a choice. Some student anyway, they have to choose to make something, right? Make a part if you modify your curriculum. And then, so in this case, the student will be doing more advanced project, right? Utilizing the knowledge and skill they learned from Engineer 101, Introduction to Engineer, right? And in the SolidWorks, or they create a model, they print the parts. In the manufacturing process, they can also introduce these concepts, more comprehensive concept in the lecture session. And because for the US, we also have a lab session for manufacturing processes, right? So in the lab session, you can also just give the students opportunity. The student will operate the 3D printer by themselves, play with them, and then create something. And then in the end, for the year 4, for the last year, senior year, and then they will be able to do some really interesting and good project for the 3D printing.
Okay, I think we got it. So in our case, we have introduction to industrial engineering. It is not introduction to engineering, but we can use that one. And for the CAD,
you can use that one. Just anyway, they have to do project, right?
Yes.
Maybe you just need to assign one project for example, you have 30 students, you don't have to assign all the project related to 3D printing, maybe just one. And then because the student will make a presentation, all the others, the students in the class will listen to their presentation. They will know, oh, okay, there's one group they are working on the 3D printing. It's pretty interesting, right? They will know, they will get the knowledge. They will be exposed to,
Yeah. So I still remember that when I was a student in Texas Tech, I saw some undergrad student, they just print like keychain, the glasses, and then hold there for their iPhone just for fun. It is just for, it is not a very serious product. It is just for decorative, right? So, but they use that one.
Students sometimes, you can imagine the students will be inspired, and then their energy is super powerful. If they, if they want to do something and then explore something like 3D bioprinting research, for me, it's brand new, like 4 years ago. I just listened to one presentation in the ASME, the AMSEC conference, that one, right? So, and then I was inspired. Okay, I thought, oh my gosh, this is amazing. So I just jumped to this area and then write a proposal, seek a fund, and then right now we have done a couple of projects, and then we have published papers. So I think the same idea to the students.
I think we have one.
Just give them the opportunity to get this idea, and then they will
explore themselves.
Yes, and then sometimes they will fly.
I think we have a student. His name is Prama. He was raising hand. Prama, can you hear me? Prama? Hello, Prama? Oh, okay. So, he has a question. He put his question on the chat. So, I am Prama Dana Aksa from Andalas University. I want to ask about the business perspective of the 3D printing technology. I noticed that in the US, CNC machine is already accessible for public use, such as some workshop that render CNC machine for people to use that. And in order to use that, they only require the user's computer design. How about 3D printing technology in the US? Are the technology is already accessible to the public as what we have seen with the CNC machine?
Yeah, Pramandana, right?
Yes.
This is a good question. I think you have an idea of to run the business in 3D printing, right? I think this will be a really good opportunity, especially in Indonesia. I think there are a lot of opportunities for you to run the business. In the US, it's already popular. Like, as I mentioned, right now in the US, high school or even middle school, they already have the 3D printers. This is open for the students in the middle school and high school. Any student have an interest, they can do the project, because in the US, the senior students, they also have to do the senior project, but it's one semester. But like the one I reach out to the project I did for the Saturday Academy, I teach one class, a group of high school students, right? So the next year, this student come back to me and says, invite me as the advisor because they want to do some project for their senior design in high school, just one semester. Yeah, they did some project in 3D printing. They said they have the printer at home in the lab. In the lab of high school. So it's already as accessible for public use, and also a lot more and more like a maker space. It's like a standard. It's like a computer or printer, regular printer. It's a standard setup, for the maker space, and some incubator in the US and the high school. So a lot of the university definitely they have, like in CSUN, our library they purchased I think almost 20 3D printers. It's free for all the students on campus to use.
Okay,
that's in the US. It's pretty popular, and also it's pretty popular in China. But Indonesia, I think that will be a really good opportunity, because I discussed this issue with my students. These students are from Saudi Arabia, from Kuwait. Yeah, they don't care about this. There's no manufacturing over there actually. but right now the 3D printing become popular, and I think 1 or 2 students of my students last year I visited them. They are running the business, a company, to provide the 3D printing services. They purchase a 3D printer, establish a company, and then they provide the service like any the local either company or customer or university, they have needs. If they don't have the 3D printer, I just establish a website. I will provide the service to. I charge like a certain amount of money to print for you.
Okay.
Yeah,
Okay.
this is a really good business, I think, in Indonesia.
Yeah,
but in the US, maybe it's already past that, the error or the period. But that would be perfect time for you to run the business in the Indonesia, I think.
Yeah, even when it was in I think 2013, 2014, I still remember that when I was in the US. So they just purchased the 3D printer for personal use, right?
Yeah. Like here, like I mentioned, Amazon, we can pretty easily get the home use metal. I'm sorry, the regular 3D printer for the FDM, only $200. It's pretty good
cheap.
quality, I think. Yeah, you can just purchase this shipped to like from Alibaba, or I think Indonesia also have a online shopping giant company. Just purchase and then deliver to Padang, and then you can run this business. I mean, you can also provide service to the university.
And I also still remember that there is a worry from the government, from the US government, how if they use this 3D printer to produce or to print the component of the gun. Right. Yeah. So that's another thing that I heard, that they need some regulation or how to deal with this new technology. Now we have another question from student. So it is about the education, but it is not about the senior design project, but it is more to she wants to get an opportunity to go to the US or overseas to continue her study. So for your Bingbing to get a scholarship to continue this her study in California State University or in other university in the US, what is the most important thing? What is the most important skill that she must have in order to get the opportunity?
Okay, I think this one is supposed to, you assume you want to get a scholarship to study abroad, right? It's not a self-fund, correct? Do I understand correctly? Because here it says to get a scholarship to continue your study in the US. Okay, yeah. If you want to get a scholarship in the US to study either in the bachelor degree and then master degree, I think there are 2 ways. One way is like your chair ferry. I think there's some federal funds or the program like CSC program. I'm sorry, not CSC. What's the Fulbright, right? Ferry.
Yes, sorry. Sorry for that.
The Fulbright. You have the Fulbright scholar program, right? In Indonesia.
Yeah, but it is very competitive. I have to say that it is very competitive.
This is the first one, and then the second one, I don't know whether you have the fund in the local government, but anyway, like right now I'm talking about the last one is if you can get the scholarship from the US university. This is pretty popular. It's also, I think the US have attracted more and more intelligent students from all the world, not in like Indian, US, China, and then Singapore, Philippines, Indonesia, right? All over the world, and also from Africa. The US, they are a little different. The universities, the scholarship typically, especially, I think you have heard some stories, news from the like Harvard, MIT, these Ivy, the league universities. In the US, the administration or the committee, they will review thousands of applicants from the worldwide, right? We really care about the soft, for the soft skill, that would be your like a communication, leadership, right? Your engagement to the local community, right? So in that means, because in the US, scholarship is not based on, we do consider the GPA, we do consider English. I think the English will be the basic a requirement, like as long as you meet their standard, like TOEFL and GRE for the master's student, TOEFL, for the undergrad student, I think you have to pass TOEFL or ETS for UK, right? So the language skill is I think it's, from my understanding, if you want to learn, if you want to study abroad, is the basic skill you have to gain. You have to get the really good English skills, including writing, speaking, right? And then the second soft skill, that would be a lot of like communication, leadership. Whether you have to, like, I think that would be perfect for your community, like whether you did something creatively, right? For example, during this COVID-19, you just gather a group of students, right? And then to help the local senior person or nursing home, right? Or you are the leader to get the group of these students to help the local community, right? This will be a perfect story, and then you will get like impressive by the committee, by the admission office, like to fight against this COVID-19. For example, you are an IE student. If you have any resources in the school, talk to the professor, and then said, okay, whether we can do something to make the PPE, right? Or to make some assistive technology, something. Sometimes these products itself doesn't have to be professional or complex. Maybe just a small thing, right? Small part, but they help your local community a lot. And then if you put this story in your personal statement, right? And then you will be much competitive, to impress the committee. And then definitely, I would prefer the student with like this background or this leadership, communication, leadership, the skills. For communication, like you maybe organize like the student chapter on campus. You have a student chapter, right? For the IE or IAE, I don't know, you have different student chapter as well. Like if you are active, engage with other members, organize different events, right? And that's another thing that you can get the scholarship. And then another one will be research skills. Like research skills, that will be if you have interest, like even from freshmen, like this is pretty popular in the US. A lot of students, even from high school, you join the research internship, right? For you, if you are the freshman, sophomore, right? You can also talk to the professor, like, professor, do you have any project? But this project doesn't have to be funded by any agency, right? Just your professor, he has some ideas. Okay, I'm really interested in this area, but I'm busy in teaching service in the university, right? As a faculty, so I don't have time to do it. But if you want, I can assign this project to you, and then we can work on that, right? So later on, that you will have, because U.S. University also really care about the recommendation letter from professor, or if you have some publication, like how to assess your soft skill in research, like you did this project and then won some competition, something like that, right? Or you work with this professor on the research project, like, and then you publish one conference paper or technical report, whatever it is, and then this will be a really good demonstration for you, and then you will get the scholarship from US. So like your chair know like if you get a scholarship, no worries about anything to live in the study in the US, because the money, they will cover your tuition fee for you to live in the US without any, the issues.
Okay, I think that's if I can add something else. So even if your scholarship is not full, maybe your study is for 2 years and then you just got the scholarship for 1 year, but don't worry, you can work in the university as a teaching assistant. From my experience, my salary as a teaching assistant is much more than my scholarship itself. That's what
exactly. Yeah,
it's more than. So my salary is more than my scholarship.
Yeah, Ferry just got a really good point. Like, just to get to the US on board firstly, even it's 1 year scholarship, and then because after you get to the US, there are a lot of opportunities, scholarship or teaching assistant, or even there's some jobs on campus. Like you can work in the library, or you can work in the restaurant, right? So this the part-time job is on campus job is legal for international students to work on campus, and then you can still get some income, to support yourself financially.
Yeah, if you work or with the to the university as a teaching assistant, then everything is free. You do not need to pay your tuition fee. The only thing that you need to buy, it is only the insurance, right? So all the money, all your salary is for you. So that's based on my experience when I was a student in the US. Okay, and I think now 11:27 in Padang, Bingbing, and I'm sure now in LA it is 9:27 p.m.
Yeah, 9:30 p.m. Yeah,
9:30 p.m. Have you got your dinner? You just got your dinner. You just got your dinner.
I did get the dumpling. So yeah, before.
I give one more a chance or to the audience if they want to ask question directly, if they have. Anyone from the audience? Hello?
Hello, Dr. Ferry.
Okay. We have Professor John Rinaldi.
No, Professor.
Okay. But in the US, if you are a lecturer, they're gonna call you Professor.
Okay.
Yeah,
okay,
even if you are just an instructor, they're gonna call you Professor.
Okay. Okay. Hello, Bingbing, Professor Bingbing. Yeah.
Hi.
Okay. I just need to confirm 2 things to you. The first is about curriculum. Yeah. It is better or not if we put introduction to engineering and technology in our curriculum beside the introduction to industrial engineering. It is better or not, because in our introduction to industrial engineering, this is about we talk about just about manufacturing system. That's not about the manufacturing technology. So this based on your opinion, it's better to put in our curriculum like one course is talk about introduction to engineering and technology. That's the first. This is not a bad question. This is just how about in USA? Okay. And then the second one is about for senior design project. It must be engineering project, or we can do any project for this one. Okay. I think that's 2 things.
Okay. I think from Pak John it is so. With us now, Bingbing, we just have introduction to industrial engineering. But when I was in Texas Tech, there is no introduction to industrial engineering. But they only what you mentioned.
No. Yeah, I think every department they have engineer 101. Like for Texas, for our department is IE 101. For mechanical engineer, they have ME 101.
Okay.
For double E, they have double E 101.
Okay.
So this, we don't have like a general engineer 101. So I think to answer your first question, I think there's a challenge. Like in the US, we don't, depends on the degree. like if you only have one bachelor degree in the IE for your curriculum, for example, for our department, right, we have two bachelor degree. One is MSc, Manufacturing System Engineer, bachelor degree. Another one is Engineer Management. But we decided to change the Engineer Management to Engineer Management Technology. So we have two bachelor degree, but we still have only one. We call it MSE 101. Like for 101, I don't know. I don't think that's, if you have two degrees in your department, maybe that's necessary to have two 101, like one is IE 101. Another one is engineering technology 101, right? Because to be honest, like discipline, right? So if you want to do anything, work in the technology, I don't know, maybe you can develop a new degree, or you can just develop a more advanced course like elective course in senior or junior level. I think this one will benefit students and your curriculum.
Okay, so
yeah, like a 101 is just introductory, course. Like I don't think they can make a big change from the curriculum or from the students' perspective. Yeah.
Okay.
But if you have two degree, I think yes. The second question is for your senior design, right? Whether we can, of course, like our senior design project, because my topics in the 3D printing for the smart manufacturing. So I only emphasize or show the project related to, the manufacturing or 3D printing, right? But we also have some other project, like if you are the IE, traditional IE, right? You can also do the project for operation research or for supply chain or for management, right? And also you can do the real project, but the challenge in the US is different with maybe Indonesia. Like in the US, based on the ABAT accreditation, right, for the senior design projects, what we did is we integrate the like a business model canvas, right? The engineer management component, supply chain component, or marketing component into the senior design of like the product I show you, right? If they made the product, they also need include how they are going to do the marketing, how they're going to solve the problem for the supply chain or for some of the components, for the operation research. So we haven't done any pure senior design projects only for like operation research or for let me see, for supply chain. No, it's only the component of your large project, because this is required by the US, the ABAT accreditation. But I think, for you it's flexible, because you don't require to do the senior design, to make the real products, right? Of course, you can do whatever you want. Like you can just work on one real project, right? You can collab with the local company, industry. Like, do you have any need to do the supply chain, like the new supply chain, digital supply chain, or industry 4.0, right? Or you can do some project like operation research for the data processing, right? For simulation. So I think that would be a really good senior design project as well, as long as it's related to the real need from the industry or from your university, and then the student will benefit or will learn from this project. I don't like that some projects just like theoretically, like operation research or supply chain, and then they just do from the paper that nothing related to the real practice. I think that one, either the both students or the faculty will think, okay, this is boring or this is nonsense. But as long as it's related to like the practice, right? And then I think that's good. It's pretty good.
Yeah, but because we care about the ABAT accreditation, so we just need to.
But I think the
yeah.
ABAC accreditation for your, I don't know, for your senior design seems like it's different with us, right? They didn't require you to make the real products, right?
Yeah, but in IBET criteria, the project must related to constraint and also the standard, yeah, engineering standard.
Oh yeah. Engineer standard, yeah. That means that you have, for example, you design something, you have to follow the different standard, right, to design, and then yeah.
Yeah, I think Bingbing, I will continue Pak John's question. So, according to your opinion, or in your case, do you have this kind of experience or not? For example, there is a group of students. They develop a simulation model, a computer simulation model for a factory, for example. And in your opinion, in CS in California State University, do you think that is okay for a senior design project?
I think so. I do believe, yeah. Like our department, like we have the collaboration with the computer science, right? The computer science, their work is just develop this app or programming or coding or system, right? That's it. They don't make any real products for computer science.
Okay. So
Same
that's
thing.
okay.
But for IE, because our department is not a traditional IE. Like in Texas Tech, the Texas Tech, they run the senior design different with us. Like
yes.
I know the senior design in Texas Tech, they do some of the work like the Professor Ahmad mentioned. It's just operation research or simulation, right? Or supply chain. Yeah, they did this way. They don't have to make a real product in Texas Tech.
Okay.
They do qualify as a senior design project because you are the pure IE department. Ours is like a combo of manufacturing and the IE, like or the engineer management. But because we don't, for our curriculum, we don't have OR or simulation class. We do have a simulation is for arena, yes.
Yeah. I just wonder about the IBET accreditation. Is okay for IBET? That's okay. Yeah. Because the IBET said there is a criteria for capstone design. It must be consider the constraint and also engineering standard. So why we ask about the project must be in engineering activity or not?
Oh, okay. Yeah, I think the way we evaluate in the ABAT, I think the ABAT visitor, they also ask the question, this is standard, the standard on constraint, that means is, for example, you are the IE student, you have to follow the standard for IE, for operation research, or for your discipline. So it's not talking about the standard and constraint is not related to the real project or not. No. It's about whether you follow the engineer discipline standard, like for IE, for operation, if you work as the operation research, right, to process this data, right? You also have some guidelines and the principle and or standard to follow, right? And for the constraint, that means it's a constraint from different technical constraint, ethical constraint, or the legal constraint, right? These are the constraints you have to consider whenever you design. For example, the simulation. For example, you did a simulation project or operation project for the local company. The company has to consider a lot of constraints, right, from their practice. Yeah, these are the ones you have to include in the ABAT.
Okay, I got it. Thank you, Prof.
Okay. I think I think that is it, Bingbing.
Okay, thank you. Yeah, it's my great pleasure, my great honor to talk with you guys. Yeah, I hope in the future after COVID-19 disappear, and then I can visit your university, right? And then because I really like the traveling all over the world. So I have been traveling over 60 countries. So I'm glad I will visit, the Chair Ferry later, maybe next year, if the COVID-19, disappears. So I hope I can talk to all the students and your faculty members, yeah, face to face. I think, yeah, thank you.
If you're gonna visit us, so I don't want you gonna stay just for 1 week, but we want you to stay for 1 semester.
1 semester.
So
sure, it's possible. Yeah.
You're gonna be a visiting professor. So because I'm sure that you can take your sabbatical leave, right?
Yeah. I can take the sabbatical leave. Yeah.
So how long
that's
that
possible.
can be?
Yeah, I will consider like I can stay there like 1 semester or something like that. Yeah.
So we're gonna assign you some class and you need to teach. Okay. Yeah, let's see. But that is we are very happy if you consider to visit us. So even if it is just for a short visit, please let me know.
Sure, no problem. Yeah.
Please let me know.
And then I think I can also see some collaboration, the opportunities, like, because in here, we also need some international students and really good students. I mean, and then we have a need, to establish collaborations with other countries, and then also maybe, yeah, we can talk later. I will talk to my dean and the chair, but my current chair will step down for next semester. So I will see, whether, we have some more opportunities, and even some 2+2 or 3+1 program, so your student can study like 3 years over there, 1 year over here. We can provide some scholarship for the outstanding students from your department, right? And then we can establish these type of collaborations. 3+1 or 3+2. 3+2 means it's 3 years in your university, and then another 2 years over here, so they can get the master degree from our department and the bachelor degree from your, yeah. So it's like a 3+1 or 3+2. Yeah.
Okay, I think this is a good start.
Yeah, so we are open to this conversation as well. Yeah.
Okay, so I will let you know. I think from our side, I think we really happy if we can collaborate with CSUN. So it can be anything. We visit you, you visit us, my student visit you, or your student visit us. So it's gonna be an exchange program. So we're gonna follow up this. Maybe we need to set up another Zoom meeting with you, your chair, me, my dean, and my faculty. So you're gonna
no problem. Yeah.
So we're gonna continue this communication and collaboration. So we're gonna expand this collaboration. It will not stop here with this lecture.
Sure, of course. Yeah.
Okay. Thank you so much, Bingbing. So again, it is a great pleasure. It is a great honor for us to have you here to share your knowledge in research and education in in California State University in Northridge. And I hope that this seminar, so the students, the faculty will get benefit from this event, and also as what we just discussed, that we're gonna expand this collaboration. We will not stop here. We will continue this collaboration, and in the future we may have exchange student, exchange faculty, and so on and so forth. And if we can do this with California State University, I think this department, my department, gonna be the first one who have a real collaboration with a university in the US. So that's gonna be a good one for us. And
yeah, welcome to Los Angeles. Like Los Angeles, Angel City. We have Hollywood, we have NBA, like Lakers. Lakers just won the champion of NBA.
Yeah.
Like last week. Yeah. So welcome. So I'm looking forward to our further collaborations. Yeah.
Okay. Please let me know if you want to visit us, and I will facilitate everything. I will do what I can do. And again, to the faculty from the Department of Industrial Engineering, thank you very much for your attendance, and for the faculty from our partner university from our neighbor in Pekanbaru, in Java. Some of them are here, Professor Bingbing. they are listening, they are watching and listening to your presentation. Thank you very much for your attendance, and don't forget to fill up the attendance list. I shared the link, and from there you can get the electronic certificate. And the last thing, this is very important for the students. Thank you very much for your attendance, and make sure that you get benefit from this event. And if you want to continue your education to the US, to California State University, if you have any question, you can ask Professor Bingbing. If you want me to ask him your question, and then I will help you guys. So please don't hesitate to ask anything to Professor Bingbing for a better future, for your future education. And I think this is it. Thank you very much, and thank you, Bingbing. Please convey my regard to Jenny, Charlotte, and William. Okay.
Yeah, thank you.
Okay. Thank you. And I think I conclude this meeting. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi wabarakatuh.
Bye, Bingbing.
Hi, Bingbing.
Bye.
Yeah.